Hello, welcome back to Energy 101. Today we're going to be talking about carbon dioxide, carbon emissions. And carbon is obviously a hot topic regarding global warming and climate change, and it's dominantly energy related. So far we've covered a lot of fundamentals about energy, our energy system, how society uses energy, how we get where we get that natural energy from, and then the conversion processes that we use to convert it from the natural energy forms that nature provides it to us into the form that society wants it, and in order to use it usefully, like heat and for heating our homes and air conditioning and electricity and so on and so forth that we've talked about. But the topic that really almost dominates at this point everything else is climate change issues, and which, as I've said, is essentially totally linked to energy and fossil fuels. So let's take a look quickly at that. The global warming gases that cause the atmosphere to change the amount of solar radiation that is transmitted through the atmosphere is CO2, but it's not the only gas. The other gas that's dominant in producing global warming in our atmosphere and climate is methane, which, as we've said originally, methane is used interchangeably with natural gas. Methane is a hydrocarbon atom, CH4, 4 hydrogens and 1 carbon that we've talked about before, and some 98%, depending on where you get the natural gas from, is made up of methane. And then there's some other stray gases with the 98% methane. But methane and natural gas are essentially used interchangeably. The other one is nitric oxide, NOx. NOx is produced when we have combustion that produces high flame temperatures. And the reason the NOx is produced, there's no nitrogen in the fuel, but there's nitrogen in the air that we have to put into our combustion process to get the oxygen. And the nitrogen that's in there, about 88%, 89% of our atmosphere is nitrogen. It gets heated up, and that nitrogen is there present with the approximately 20%, approximately 20% oxygen, and that gets formed with nitrogen. I said that nitrogen makes up 88, 89%. That's should have been 78, 79%. So the high temperature causes some of the nitrogen to react with the oxygen, even though that's not the whole purpose of the combustion process, but it just happens almost unavoidably. And then the other gas that produces global warming and climate change effects are refrigerants. Refrigerants that we use in our refrigerators, that we use in our air conditioning systems. And that's had a long history. We originally in the 90s had concern about refrigerants, commonly called Freons, which was a brand name of DuPont, that has quit being utilizing that name because of the depletion of the high altitude ozone. And the ozone is there and absorbs solar radiation. If we get rid of the ozone, which the refrigerants that are released into the atmosphere do, kill some of the ozone, then that causes more radiation and causes increased radiation to the Earth. But we changed refrigerants, the industry did, and the whole world essentially changed from those ozone-destroying refrigerants to more suitable refrigerants from that viewpoint. But some of the refrigerants still cause global warming issues. and those are fluorinated gases. So those are the four gases that cause our climate change and the global warming effects. Here's a pie chart that shows what percentage each one of them contributes. This comes from the Environmental Protection Agency and the U.S. EPA, and you can see 84% of the gases that cause global warming, the effect is carbon dioxide. Methane causes 10% of the global warming effect, and nitric oxide's 4%, and then the refrigerants 2%. So, and then there's some other gases that cause a small impact. By the way, the methane, this does not mean that methane is approximately 12 times or 8 times less in amount of gas than carbon dioxide. What it means is the effect of the methane that we're releasing to the atmosphere causes about 8 times less global warming effect. But each methane molecule causes about 25 times as much global warming impact as a molecule of carbon dioxide. So all that's got to be factored in. But this is the impact of these gases on our radiation absorbing atmospheric qualities that cause global warming. And so obviously carbon dioxide is the dominant one we need to worry about. But the carbon dioxide, methane, and nitric oxide dominantly, of course, comes from fossil fuel utilization. If we get rid of fossil fuel utilization for energy, then we would essentially totally get rid of the big impact for any climate change effects. This shows the trend of carbon dioxide emissions by country. We need to, in order to determine what we can do about it, we need to look at who's producing it. We now know what gases are causing it. Let's look and see what countries are producing the carbon dioxide that's 84% of the impact. Well, here the green line is the U.S. You can see we were the champions, unfortunately, in carbon dioxide emissions. On the left, it shows the metric tons of carbon dioxide produced per year, and we're up about 6 million, and 6,000 million tons of carbon dioxide. Those are metric tons, so small 10% difference between a metric ton and an English ton or British ton, which is regular tons of what we use here in the U.S. But from a relative scale, you can see that China surpassed the U.S. back in the late 90s. So late 2000s. And so that is a problem, and unfortunately, China and U.S. don't have any hard regulations that set severe hard limits on how much CO2 we're going to produce and how to reduce them. We have some policies that will help that, but it's difficult to turn it around. And the rest of the countries are shown down there in the bottom, and you can see that when you get down to India, Russia, Japan, etc., those are fairly small. World CO2 emissions, here they are a little bit clearer. China's 25% of the total CO2 emissions, North America 21, Europe 14, Middle East 6, India 5, Russia 5, South and Central America, etc. Let's go to the next slide, which is a complicated slide, but it's got a lot of information on it. Let's study it for just a minute. This, by the way, comes from a organization and website called CO2now.org, and the data comes from the EIA, but the graphics was done by CO2 Now. The circle size is proportional to the amount of CO2 each country produces, and it's divided into regions. So let's start with the U.S. over here on the left. and North and South America. And so, North America. North America is, of course, Canada, U.S., and Mexico. And you can see we, of course, dominate North America with, that's shown there with 5,425 million tons, which was on the previous graph. So that is the North America. If we move, and you notice it's got a 2 by North America, by the U.S., and that means we're number 2 in countries. If you move over to the blue on the right over here, then you can see that we are we have China, and China is the champion now, past us at 7,711 million tons. We're number 2 after that. If you look at the rest of Asia, you see that you have India is number 3 behind America, and they're down here. India, number 3, and then you have Japan, which is number 5 right here, and Australia, which is number 15, and Indonesia, which is number 16. So you can look at all the countries that make up the Asian region. But as a matter of fact, this circle right here is the sum of all of the Asian countries that are shown individually by the solid circles. If we look at some other countries, other regions and countries, you can see that Eurasia, which is basically Russia and Eastern Europe area, you got Russia, that's number 4. That they're behind India, that's number 3. India was number 3 in Russia, so we down from 1 to China's number 1, U.S. is number 2, and India is number 3, and Russia is number 4. So, and here's the black circle here shows the region of Eurasia. Europe is dominated by Germany right here. They're number 6. And then I believe Italy is next in Europe. They're number 17 in the world. And UK may be higher than that, number 10. UK is number 10 in front of Italy. But you can see the rankings right here, and this is 2010 data. By the way, it's a little bit complicated since 2010 in getting, or a little more difficult getting this data, and that's due to the fact that the responsibility has transitioned for getting this data and compiling it and put it on the website is transitioned from the Energy Information Agency, part of DOE in the U.S., to EPA, the Environmental Protection Agency. And that transition has caused a little bit of slowdown and gaps in the latest data being available, and it's shown in a little different format. So it's you have to be careful about what data you're looking at and the one-to-one comparison. You got Africa down here as a region, and you got the Middle East. And the Middle East, you can see, is dominated by Saudi Arabia, which I believe is number 11 in the world, and you have Iran that's over here, and Iran is above Saudi Arabia. Iran's number 9 in the world, and Saudi Arabia is number 11, and you have other Middle Eastern countries. What haven't we looked at here? We haven't looked at South and Central America. That's dominated by Brazil, and for South America, Venezuela is significant, and Argentina is also significant. But if we're going to solve the world climate change problem, which it is a world problem, one country cannot solve it. If the countries that can have the biggest impacts are, of course, China and the U.S. And it seems that China and the U.S. are unfortunately among the countries that are the slowest to make changes, and China is growing so fast economically, bringing their people up the standard of living scale, that it's going to be difficult for them to keep their CO2 emissions down, or even slow the trend down to a large degree. So this is the world situation regarding global warming gases, and dominantly that means CO2 that comes from burning hydrocarbons, carbon and hydrogen fossil fuels. The more carbon you have in the fuel, the more CO2 you produce. Methane produces less CO2 than coal, because coal is just made up of carbon, whereas you're reacting carbon to CO2, whereas CH4 is also using hydrogen reaction with oxygen that's producing energy and doesn't produce any CO2. So those are the two fossil fuel gases at the two ends of the spectrum regarding the hydrogen-carbon ratios. But down here, just before we move off of it, is the world. And the percentage down here, by the way, shows the latest trend, which I believe is 2010. You can look at this site. It's a great site for information. Looks like it's very credible. They get their data, as I mentioned, from, in this case, from the EIA, and that is reputable data, but they're no longer putting that data on their website. The new data, anyway, has been transitioned to the EPA. So that's the world picture, and it's a difficult thing to change it, but that's where we are regarding who's producing the gases that are creating all the controversy about global warming and climate change that is argued about and debated and causing major concern around the world, actually. So if we look now look closer at home, back at home, and look at the emissions by sector, where the CO2 is being produced. Again, this is 2010 data coming from the EPA. You can see that the electricity sector dominates in the amount of CO2 that is produced in this country. Electricity production from all types of fuel, including renewables, which of course do not produce any CO2 to speak of, is 40%. So the electric power industry is unfortunately the one that we need to work on to have the biggest impact. Transportation means oil consumption in our vehicles, trucks, airplanes, dominated by automobiles. Automobiles that burn oil. So we got oil, and the fuel that dominates electricity, of course, at least is the largest chunk of it, is coal. So we got coal and oil as the burning that's causing the biggest CO2 emissions and causing the biggest problems. Industry is 14% of our CO2 emissions in the U.S. One of the big ones there is cement production, and that is just in the cement manufacturing process, and it's a very large producer of CO2. Residential commercial is about 10%, and other non-fossil fuel combustion is about 5%. That means things like refrigerant emissions. So that's the big picture for CO2 emissions worldwide, and narrowed down to the U.S. And we'll get down to, now that we have that background, we can look at what's the impact of different technologies on reducing CO2 emissions in the U.S. Thank you. See you next time.